I hope you had a good 10-minute break. And let me introduce Mr. Peter Burkholder. Mr. Peter Burkholder is a custom success engineer with Chef Incorporated, where he works with enterprise chef customers to ensure successful automation, strategy, and implementation, and advocates for adoption of DevOps culture. Prior to Chef, Peter led operations work for DC area startups, nonprofits, and the federal government, where he was an early champion of automation and configuration management. Peter is formally trained as a geophysicist and earned his Unix job running field computing systems in Siberia and Antarctica. Let's welcome Peter.
Thank you, Varsha. Is everyone having a good day? Yeah, I've been learning so much. This is not going to be quite as mind-blowing as Khaliv's talk was. Well, maybe it will be. It depends how your mind is blown. We're going to go from this very big picture of what technology and cloud-scale computing can do to a little bit more down in the weeds. And this will be taking a different look at what you can do with Google Compute Engine than some of the other talks we've done today, but it's certainly complementary to that. I am indeed Peter Burkholder. I will be giving some contact information again at the end of the talk. And thanks to that introduction I just had, I don't have to give a whole lot about my background. I did get started in workstation-style computing as a graduate student when I was sent off into the field with a few computers and a stack of manuals and said, good luck getting these systems to process data in the field. And over time, I found I had a greater knack for running computers, systems, and networks than I frankly did for looking at seismograms all day. So I have followed that through a path in computing at different scales and have been with Chef Incorporated now since this summer. Now, what I'm curious about is a little bit more about who you are. First of all, how many of you would consider yourselves more development than strict operations? Yeah, that's what I thought, as I expected for this conference. Now, do you know where your nodes are? Are they in the cloud? Are they in the data center? How many people here have physical hardware versus largely virtual computing systems? A few of you. How many of you are in AWS? How many of you run operations in Google, either App Engine or Kubernetes or GCE? Okay, just a few. Good. So the beauty of computing at scale is that everything that we do now is a distributed application in some sense, if it is anything more than what runs on my iPhone. And in the simplest tiered architecture, we might have a web server, some back-end apps, and a database. And if you are working in a startup, getting things rolling in your platform, you get your development environment up, cool, it works. You move stuff into your first production platform with maybe a suite of web servers, a few app servers, and let's say that's MongoDB in the back end, since Mark was talking about that earlier. And you think you're off to a good start. And then, all of a sudden, you need, or has been my experience, you need consistently designed QA environments, load testing environments, pre-production environments. A different customer over there wants to test a different branch of your application. The developers need more and more environments in which to work in. And how do you scale that out in a consistent and reasonable way without taking a whole lot of money, a whole lot of time, and ending up behind a big pile of poo? Well, there are better ideas than trying to stand things up manually, so to speak. And I'm not actually going to try to use this word today. It was in the description of my talk, but whether you call it this or whether you're talking about automation, testing, collaboration between teams, reducing bottlenecks, theory of constraints, lean. It all comes down to finding a better way to consistently build and release and quickly adapt your applications to grow your business, to grow your organization. And one tool for that is Chef, and I'll continue here with this cookie cutter theme, even though that has nothing to do with Chef right there. Are people here familiar with Chef? Puppet? Ansible? Okay. Well, in common with those, Chef is a language. It is a DSL in Ruby that describes compute resources in a platform-independent way, and those resources are implemented across different platforms by provisioner libraries that help abstract away some of the details behind those resources. And those resources could be things such as users, a configuration file, a network configuration. Chef is also a service. Chef Server 12 is coming out now, and the server provides the code that you've written describing your resources as packaged libraries called cookbooks, and the server also provides discovery of resources that are distributed across the nodes where Chef is running. In this case, by Chef is running, I mean Chef as a client, which consumes the code from the server, as well as attributes that have been defined depending upon the data available on the machine. What platform am I? Am I 386 for some reason, or 64-bit? Am I Debian or Ubuntu or Windows? And builds a model of how the system should be in memory, and then uses that model to converge the node to a desired state by acting on those resource objects. Well, how does Chef play in the cloud? And the answer is that the power of a language to neutrally describe a computing resource scales out very well beyond just the description of what might be on the node, what I mentioned earlier. Chef provisioning is now an early release from Chef that provides and extends the language to describe resources within a data center or a cloud, such as a machine, a batch of machines, disk, remote disk, and there is also an early library for specifically working with GCE resources, Google Compute Engine resources, within Google Compute Engine, describing disks, instances, networks, firewalls. And since we're not describing resources on our node per se, the Chef client runs from a provisioning node that takes the code and uses that to push that description of code out into the platform of question. So to that earlier diagram, we add a provisioning node and somewhere a Chef server. And I'll see if I can get a live demo here to work, where we're going to stand up a application in GCE that is just a web server to backend Python apps, and for the sake of the demonstration, a standalone MySQL database instead of using Google's resources. And and this is a description of one resource within GCE. In this case, it's an instance, a web server. The key values are there at top. What's the standard image that we're booting from? What tags we're going to apply to the server, and that goes both into the GCE metadata and also the metadata that is kept on the node within the Chef server, and then an initial run list with escaped here that is going to have a Debian base role, and then on top of that, we're going to run the balancer recipe. And then there are different recipes, as we call them, extending the cooking metaphor, of course, to describe the database and the app servers. And so the master recipe then just includes those various recipes. And even if I don't have a significant bandwidth here, I should be able to run this because the API calls are fairly lightweight. Client-z-r DC DevFest. And only that's supposed to be a Z. That means I'm using a local. I wasn't anticipating having to crane my neck like this. Chef client-z-r DC DevFest. And we will create a QA environment. Dash environment, QA. Wah, wah, wah. Oh. So while that runs, let's talk a little bit about GCE. You're familiar with these terms by now, and since I'm relatively new to GCE compared to AWS, I'm going to go ahead and not shy away from comparing it directly against AWS. But Google Cloud Platform, I think you got started in 2007 with Google App Engine, which started just with Python, now supports a number of platforms. To that, we have the cloud storage that's been discussed today, the cloud data store for large data store, a MySQL-like cloud SQL database system, BigQuery, which we just heard about from Khalid and other talks today, and the API service cloud endpoints. Now, the
an hour or two. Preferably, we'd have working code demonstrations at the end. I much prefer whenever people make things rather than
it's
just
my other personality.
So at the end, we're going to give you a warning probably around 4 o'clock to kind of start getting things ready to present. Starting at around 4:20 or 4:30, we're going to have...
Is it just me now? Well, some features I've liked about Google Compute compared to AWS is that there's an auto migration feature. I always used to get these sort of notifications that my instance was going to be shut down. Instead of doing that, my instances can be live migrated to another rack running in the data center that's not scheduled for maintenance. If there is a shutdown of your box, it can be automatically restarted. There's consistent internal DNS. The node that I start up here as QA Web Server 0, if I shut it down for a month, bring it back up, it'll still be the same name. And the internal DNS is actually usable. I have a project called DC DevFest, and these nodes come up as QA-webserver-0.dcdevfest.internal and dev web server 0 dcdevfest.internal. So it really, from an operations perspective, just simplifies things a lot. The billing is certainly more fair. 10 minutes, you only pay for 10 minutes when you spin up a node and destroy it, and then billing is per minute thereafter. There's none of the complex mathematics that goes into buying and laying out reserved instance money up front. Simply, the longer you run the instance, the less expensive it gets. The metadata that's attached to the node, from a security perspective, I really like that you can delete the metadata after you start up a node. And what I mean there is that when you start up a node, you have a frozen image of the machine that acts as a boot disk. When it spins up, you actually want it to take on a personality of its own. what is its name and its role going to be, and you might also want to provide credentials such as keys, passwords, or validation PEMs. And in this case, in GCE, after the machine comes up, you can delete that metadata. So if there is someone on the box who wants to poke at it, they can't get to it. It's no longer there. I think we've already seen the G-Cloud command line tool being demonstrated here today. Authentication is simple and straightforward, has a very rich API, command line tools. They now have auto-scaling in beta, load balancing, support for image snapshots, image templates, the Kubernetes container engine, and I understand that VPC is in the works. So it has a lot of parity in AWS for things that really let you get rolling for a tiered infrastructure. The pricing is also very competitive. I realized on the way here today, oh, people are going to want to know how this costs. It is on demand, 10% less than AWS for a medium instance. It's half the price of Azure. DigitalOcean is a little less expensive. I haven't looked enough. I worked with DigitalOcean, but haven't done a feature-by-feature comparison. For those of you who can't like to think in terms of monthly prices instead of per hour, those are the longer-term pricing. Or, I'm sorry, that's those same numbers multiplied by 720 hours. So let me see if this these nodes have come up. OK, I have something got renamed in my cookbooks. So no live demo. Sorry, I live on the edge, and you fall off sometimes. And of course, it worked here in this room 3 hours ago. So unless you guys really want me to stand here for a few minutes in anguished silence while I try to figure out what's going on wrong? Nope. OK. So if I didn't have this damn syntax error, I would be demonstrating now how to scale this out to a scaled out version. And in this case, I've wrapped the same instance call simply in a bit of Ruby that says, take an attribute by default 1 and do this number of times for this particular instance. And also provided a little bit of logic around the naming so I can find my various web servers, since I'm going to now have more than one of them. And then for a particular environment, say a production environment, I'm going to say I want 3 database instances, 2 of the app A and 6 of the app B. And in this case, since I have actual code on the next slide instead of a screenshot, I might be able to copy and paste it. So let's talk about testing while that's running. There's that word I'm not going to say again. Those of you, since most of you here are developers, you're familiar with test-driven development. It is all rainbows and ponies, of course, when you do testing. But it really does make life so much better now that we actually can do not just test-driven development of code, but test-driven development of infrastructure. And over the last few years, since Chef was first had a broad release in 2009, there's been a very rich ecosystem of testing that's been built around it, to where we have in 2014 a pipeline that you can send your code through. So starting with our code where we describe, say, a user package service. You can, of course, run linting tools, style tools like Rubocop over it. There is also a chef-specific style checker called Food Critic, which warns you away from bad practices and toward good practices. There is, on your development box, a RSpec extension called ChefSpec, which takes that code that you've written, compiles it in memory in a fake node environment with fake attributes, and then introspects into those objects to make sure that the specifications you've had for those attributes, or for whether they're actually effective or not on the machine, meet the assertions that you're making. And there is also, on the integration side, a suite of tools called Kitchen CI or Test Kitchen, which uses a YAML specification to spin up nodes in a platform of your choice, whether that's locally on Vagrant with VirtualBox or VMware, in AWS, in GCE, or now or some other private cloud platforms, to set up an instance, write tests against it in server spec, assert that they're true, and that test passes, and then you are good then to move that code onto your Chef servers for implementation across different environments. And if you're moving code, your application code in sync through your pipeline to production, you can match the versions of the code to the versions of the configuration that is specified by the cookbooks. So I'm not sure if it just went forward or back. Let's go back here to the test. Is it still running? OK, well, I guess that'll leave the talk a little bit shorter, but that'll give us more time for questions. So to summarize quickly where we are with GCE plus Chef, as an infrastructure as a service platform, I found GCE a very compelling offering, and if I were starting up today, I would strongly consider it perhaps in favor of or in addition to one of the other public cloud platforms. And the combination of Chef plus infrastructure as code gives you an experience that is testable, repeatable, and can also work on scale. That's not to say, though, that everything here is paradise. How many of you ever actually tried to talk with a human at Google besides at a developer conference? It's kind of a dicey proposition. I was trying to get started with GCE, you're nodding, and the damn thing would not take my credit card number, would not take my credit card number. Different platforms, different browsers, different credit cards, file a ticket, I'm tweeting at them, it's like, hey, help me out. They said it would take me 2 days to get back to me, and it's not as if I could even sign on as a paying customer, because they couldn't take my credit card. It was 5 days before they got back to me. That said, though, when I wanted to extend the quota on my account so I could demonstrate a whole bunch of machines coming up here for this conference, which I couldn't just demonstrate. But in that case, they got back to me within 78 minutes and increased my quotas. The code I was showing earlier on how to specify instance resources within the Google Cloud Platform is not yet integrated into the broader Chef provisioning system, which aims to have a platform-independent way of specifying resources so developers can take that to spin up local instances in virtual machines or in Docker, and as you move into operations, you can use the same specifications of machines with the adequate run list to roll out onto different platforms, including bare metal. And So there's some things that work, some things that don't. Most of this stuff just works. If you run into a bug, though, please don't hurt me. There's plenty of places to file a bug against Chef, or better yet, open up a pull request. And the contact information that I had earlier, all of this information about the Chef ecosystem is available at our site, getchef.com. If you want to learn how to write code to effect changes on machines, if you go to learn.getchef.com, we will spin up a CloudShare instance for you, either in RHEL, Windows, or Ubuntu, such that you can SSH to that machine, go through a guided tutorial, see that things converge, and then shut it down when you're done. So there's no need to get started learning Chef by having to install anything other than a browser on your laptop. There's also now a Chef development kit for Windows and Unix-like operating systems that provide all the tools to get started with Chef. For Google Cloud, the promo code for ChefCon 14 still works, $500. That is what actually saved me in getting started with Google Cloud in last week. No, I'm sorry. They actually did go through to my credit card. But that still works if you want $500 in starter credit. And the content of this talk, including code for what I assure you is a working demo, is on my GitHub repo. So, questions? Yeah.
So it's kind of outside the use case I guess we're discussing here, but can Chef actually deploy to physical machines as well?
There is now support for Pixie booting with Chef provisioning. Have you used Puppet Razor or other configuration management deployment tools?
No. Our wise old gray-bearded sysadmin left, and he managed our development environment. It's been handed off, and I've found out it's like a hellish bunch of shell scripts. So we're looking for a way to essentially easily spin up new dev PCs on physical hardware.
So yeah, instead of trying to figure out what was going on with all those shell scripts, you're going to want to choose a configuration management system, and preferably Chef, but any of the major contenders is going to be better in the long run, not only than shell scripts, but better than using someone else's shell scripts.
Cool.
Yeah.
Is there like a collection of provisioning scripts that people kind of put up for free, where you can go and download a generic image and then throw it on the machine or something?
So are you wanting to?
Like for instance, I don't know very much about Chef or Vagrant.
Okay.
I know with Vagrant they have like a Vagrant hub or something where you can go and say, here's a generic Ubuntu, 14, whatever. You can just grab it and throw it into a Vagrant installation.
So yeah, the tooling that provide with, let's say you're running a Mac machine, you've downloaded Chef DK, VirtualBox, and Vagrant. You can pretty much start using Test Kitchen right out of the box, because it goes ahead and just pulls down a box from the VirtualBox repository, and then you can work on applying different cookbooks to converge that virtual machine the way you want it. So, I mean, the breadth of Chef now is that the sweet spots are really in development and using it in development platforms to spin up consistent images, whether that's VirtualBox, VMware, or Docker, and then using that to have consistency across your application toolchain. And then also at the very large scale, enterprise level, where at Facebook and Yahoo, Chef is managing 50 to 100,000 nodes for keeping the underlying infrastructure synced up. Google has their own way of doing things, but to each their own. Well, I think that gives us the opportunity to go and get coffee a few minutes early. I am around, be happy to talk with any of you about your present setup or how to improve it, or if you're using Chef, any success stories or questions you might have about making things work better. Oh, sorry? That would help. There we go. And I'm surprised that I'm the person not working for Google who came in with a promotion code for you guys to get $500 of free GCE credits, but go to town. It's not my money.